All right, so today we are going to do chapter 4.4. So we're going to talk about lines of best fit. And so a scatter plot is a graph that shows the relationship between two data sets. So it shows the relationship between two data sets. The two data sets are graphed as ordered pairs in a coordinate plane. And then scatter plots can show trends in the data. So whenever we're looking at a scatter plot, really all we're trying to find is, are there any correlations in the data? Are there any trends that we can see? So correlation, this is a relationship between data sets. You can use a scatter plot to describe the correlation between the data. So below you have positive, negative, and no correlation. So for the positive, this is as x increases, y increases. Negative correlation, as x increases along the x-axis, y decreases. And then this last one, no correlation, this means that the points don't show any sort of pattern. Okay, so let's keep this in mind and talk about lines of fit. So a line of fit, this is a line drawn on a scatter plot that is close to most of the data points. So when we are doing this, we want to first make a scatter plot of the data to decide whether the data can be modeled by a line. If it doesn't show a correlation, then we can't draw a line modeling it. But if it does, then we can model it by a line. And then step 3, we want to draw a line that appears to fit the data closely. So there should be approximately as many points above the line as below it. And then step 4, we want to write an equation for the line using 2 points on the line. So the points do not have to represent actual data pairs, but they must lie on the line of fit. Okay, so first let's talk about positive, negative, and no correlation. So this first one, vehicles owned. We can see that we're talking about the difference between our age and vehicles owned. So we don't really appear to have any sort of trend here. So the number of vehicles owned does not depend on age. So it doesn't matter what age you are, you can have as many vehicles as you want. And so there's no correlation here. And then part B, we have temperature and coat sales at a store. So we can see more of a trend here. And so as the temp increases, the number of coat sales decrease. So the number of coats sold decreases. So we do have a correlation here, and it is negative because as x is increasing, y is decreasing. Okay. And so now let's do a couple examples. So we want to first make a scatter plot of the data, and then we want to be able to tell whether the data shows a positive, a negative, or no correlation. So off to the side here, we want to graph the age of cars and the value. And so age of cars, this is along the x-axis, and then the value in thousands is along the y-axis. So I've already put this together, and so if you were to put this on your own graph, just make sure that when you're doing this that you have all of the points that you need to have on there, and you have it spread out enough so that you can see a general trend. If it's all kind of smushed together in one little area, then it's harder to see trends. So this might take a little bit of kind of guess and check at first to try and make sure that you have the right numbering on your axes, but the further apart you have your data, that just makes for a bigger picture, and so we can see more easily what's going on with the data. So if we were to plot these, we're just plotting these as points. So for example, this is 1 point. This is a second point, third point, so on and so forth, right? And so we want to, oh, I can't erase this. And so what we want to do is just go ahead and plot these points first. So I'm going to start with the first point, so 1 and 24. So when I plot that, I'm right up there. And I am just kind of estimating this a little bit because I know that I'm not going to be directly on a point. I'm just kind of estimating. And then 221 is going to put me right there roughly. And then 319 right there. And then so on and so forth. So you can just kind of fill in your scatter plot. And remember, when we're making a scatter plot, we're not connecting the dots. We're just putting the points up on our graph. And that's it. So we can see a trend here already. As the age of your car increases, so that as the age in cars go up, the value goes down. So as the age of your car increases, the value of your car in thousands goes down. So we do have a correlation here. It is, if you want to think about it, we're going down. So it's a negative slope that our line would have. So it is a negative correlation. Okay, let's move on to this one. So for this one, the table shows the weekly sales of a DVD and the number of weeks since its release. So we want to write an equation that models the DVD sales as a function of the number of weeks since its release, and we want to interpret the slope and y-intercept of the line of fit. Okay? So first, step one, we want to plot our points here. We want to plot our points. So remember, when we are plotting points, these are going to be our points. So 119, 215, 313, so on and so forth, right? So we're just going to go ahead and plot those on our graph. And so 119, remember, we're just kind of estimating these a little bit. And again, I have already labeled our graph. And so if you're labeling this on your own, just do the best you can to spread out the data as much as you can. And then 215, our second point, is roughly about there. 313 and 411, 510, 68, 77, and 85. So this is roughly what our scatter plot looks like. So step one, we want to make a scatter plot. We've already done that. Cool. And so step two, what we want to do is decide whether it can be modeled by a line. So it does seem to have a correlation here, and it does look like it's going to be a negative correlation, just like before. So it can be modeled by a line. And so step three, we want to draw a line that appears to fit the data closely. So as close as possible, we want to draw a line that appears to fit the data closely. Okay, and then so up on the graph in blue, I've kind of done that already. So this is like the general trend that we have going. And so if you notice, I do hit some points, but I have just about as many points underneath the line as I do above the line. So underneath I have 3 points here, and then above the line I have 3 points. So remember back to when we were just talking about definitions, when we're drawing our line, we want approximately the same amount above as we do below. So then step 4, we want to write an equation, and I'm going to use 0.510 and 68 because those are the 2 points that I'm hitting here on my graph with my blue line. So my line of fit, I'm hitting 510 and 68. So first, in order to write my equation, I want to find the slope first. So slope is that equation that's m equals y2 minus y1 over x2 minus x1. So if I were to set this up, I would get m is equal to 8 minus 10 over 6 minus 5. And so that will give me -2. So that's our slope. And so now what we want to do is take that and write that in an equation. So I'm going to use point slope form here. So I just used any of the points will work. You'll get the same thing. So I used 510 for my point. And so I just plugged it into my point slope formula. And so I have y minus 10 equals negative 2 in parentheses x minus 5. So then if I were to simplify this a little bit further, I need to distribute that negative 2. So when I do that, I get y minus 10 equals negative 2x plus 10, because negative 2 times negative 5 gives me 10. And then now what I want to do is add 10 to both sides to get y all by itself. So when I do that, I get y equals negative 2x plus 3. All right, so now that we have our equation that models DVD sales, we want to interpret the slope in the y-intercept of the line. So our slope here is negative 2. So this means that sales are decreasing by about 2 million each week. So roughly 2 million each week. That's how much sales are decreasing. So that makes sense because our line kind of has a negative slope to it, so it should be decreasing. And so our y-intercept here is at 20. And here, our y-intercept really doesn't mean anything for us. So it doesn't tell us anything about the data, and we're going to get more information from the slope. So our y-intercept doesn't really help us here. It's kind of just some arbitrary number because of the way we drew our line of fit.